In the second part, we're going to look at how to find the inverse mod 29 of a number, actually of an entire matrix, using the Wolfram language. You should have already watched the video about the Euclidean division algorithm and how to find the inverse of a number in the mod 29 number system by hand. It's an important fundamental algorithm in number theory and mathematics in general, and so it's a really good algorithm to understand and know. But I will show you now how we can do that effortlessly on the computer. So there's a nice little function in Mathematica called power mod that does this for you, and all you have to do is tell it the number you want to find the inverse of and the number system that you are working in. So what this is telling you is if I say power mod 27 negative 129, 27 is the number I want to find the inverse for. The negative 1 is indicating that I want the inverse, and 29 means in the mod 29 number system. So remember, in Wolfram, functions have square brackets around their parameter lists or around their inputs, and again, they always start with a capital letter. So if we shift enter on this line, it tells me 14. Well, that means 14 is the inverse of 27 in the mod 29 number system, and you can check that out by hand if you don't trust it or you want to know. But there you go. So any one of these numbers we can find the inverse of very quickly. So if we look down, back at my my matrix here, my augmented matrix, I was left with 27, 45, and 135. Well, I can power mod 27, which I already did, and got 14. Okay, so I'm going to multiply the first row by 14, and think about what that's going to do. Right, as I take the row here, and I can't highlight that row. There we go. As I take that row and I sort of turn it and multiply, I'm going to be multiplying the first row by 14 and the second and third rows by zeros, right? So 14 times 27 is going to be 1 in the mod 29 number system, and so I'll have produced a 1 here, right? And then I will also multiply 14 times these three numbers. Likewise, I did this earlier, power mod of 45. I can do that right here and show you real quick. Power mod of 45. Mod 29 here is 20, which is where I got this number. And then 135. And notice 45 and 135, neither of those is in the mod 29 number system, but I can still just use those, and the Wolfram language will mod it for me before it finds the inverses, and so it's all good. So 135 is 26. So I do this, I multiply this transformation matrix, that's going to produce for me the identity here on the left-hand side. And on the right-hand side, it's going to give me, lo and behold, my inverse. Why? Because of this equation, right, that we started with. We multiplied over on this left-hand side a bunch of a bunch of matrices, right, of this form, okay? On the left-hand side, we did this one, and then we did another one, and then we did another one, and eventually that produced for us finally the identity matrix here, and so the identity times the inverse must be the inverse, and so in the augmented matrix, what that means is that the right-hand side, which started out as the identity because of this, now ends up being the inverse that we are looking for. So, as this final step, we can go ahead and actually multiply these. Now, I don't have this in my augmented matrix, so if I just, if I do this real quick, I can say, 14, comma 0, comma 0, 0, comma 20, comma 0, and 0, comma 0, comma 26, dot, and then my matrix here, 27, comma 0, comma 0, comma 2, comma negative 4, etc. Now, normally I would have had this stored in my augmented variable, but I didn't set that up ahead of time, so I'm just doing it directly. Hopefully I don't mistype anything. Okay, so there's that dot right here indicating the multiplication. If I execute this, I get this matrix, right? This list of lists, and if I look at that as a matrix, it looks like that, which is hideous because the numbers are huge, right? And didn't I just say if I multiply by this matrix, I'm going to get 1, 1, 1 down the diagonal? It doesn't look like 1, 1, 1 at all. But what we have to realize is we haven't taken the results of these products in the mod 29 number system, and so we have to mod all these numbers by 29. Which looks terrible because, you know, there are 3 plus 9 is 12 numbers that I have to do this to, which looks kind of, I don't know, tedious, right? You easily do this on the calculator, just divide each one by 29 and subtract off the whole parts and figure out what the remainders are. But there's a much easier way in Wolfram language, and that is using the mod function. So, mod. What do I want to mod? Well, I want to mod this last matrix that just popped out. So I'm going to put a %. Remember, that means the previous output. And I want to mod that into the mod 29 number system. And so that's mod % comma 29. If I execute that, lo and behold, I get this result. And if I want to look at that as a matrix, I can do that again too. And I get this, right? And there indeed is my identity on the left-hand side, and on the right-hand side is my inverse, which I have here. And so there we go. I found my inverse of my original key matrix, and I can use that inverse now to decrypt my message. So good luck. If you need any help, let me know. Thanks.